Welcome and welcome back to Geospatial Talks with Mingosa. In today's video, we're going to learn how to perform change detection in QGIS to map urban expansion using Landsat imagery. We'll compare images from different tiers and identify where new build-up areas have developed over time. If you haven't watched my previous video on calculating spectral indices for NDBI and NDVI, please do so. Let's get started. What is change detection? Change detection is a process of comparing satellite images from different tiers to identify changes in land use and land cover, especially the growth of build-up areas. And why is it important? Change detection helps us to monitor urban growth over time. It supports urban planning and decision making. It also identifies land use conversion, vegetation, and build-up areas. And it also provides evidence for sustainable development. For this particular video, the data we're going to use are Landsat imagery of the same season for the year 2020 from January to December, and for the year 2025 from January to December. And the bands we're going to use for this lesson are the bands 4, which is the red, the band 5 near infrared, and the band 6. And the indices we're going to use are NDBI for build-up areas and NDVI for Vegetation Index for the year 2020 and for the year 2025. Before we continue with our change detection procedures, ensure that the imagery for NDBI and NDVI have the same projection and alignment. And to do so, we're going to right-click on the layer, then go to Properties, and on Properties, you click on Source. The projection used and the extent are UTM Zone 37, and for the other one is the same, so they have the same projection. So I'm going to click this NDBI and NDVI imagery to my area of interest. So I'm going to add my boundary shape file to this project. On your browser pane, navigate to where home is, and I'll navigate to the folder where I've saved the boundaries shapefile, and the shapefile is here. So I'm going to drag and drop it to my project. So I'm going to change the color to no fill. Right click on the layer, then Properties. Fill color, we're going to use transparent for the color, and then click on Apply. Okay. Now we have our Kenya boundary shapefile, and it looks a little bit messy, but let's focus on our area of interest, which is Nairobi County. So I'm going to right click on Kenya word layer, then click on Open Attribute Table to select our area of interest. So I'm going to click on Select Features using an expression. The window will pop up, and on the feature geometry ID, we're going to select Field and Values. Click on that, and that will appear. So I'm going to select county by double clicking, then use the equal sign, and for the value we're going to type Nairobi and click on all unique, then double click on that. So we'll have this expression, and then click on select features at the bottom. Then we're going to close that window. So if you zoom into your image, you'll see that Nairobi County is already selected. So we are going to export the selected feature by right-clicking on Kenya word layer, and then click on Export and Save Selected Feature. And we're going to save it as Nairobi County. Then click on OK. So we're going to toggle off the Kenyan word shapefile because now it's not useful, or we can either remove it. This is our area of interest boundaries, but let's now change the fill. Right click on the layer, then Properties, and on color we're going to change the fill to transparent fill, then click on Apply, then Okay, so now this is our area of interest boundary. So the next thing we're going to do is clip our NDBI and NDVI imagery to our area of interest. Now let's clip our raster layer. I'm going to click on the raster and then click on extraction, and you're going to clip raster by mask layer. The layer we're going to clip is NDBI 2025 and the mask layer is Nairobi County, and let's assign a specified node data value to 0. We're going to save our layer. Let's click on this drop down and save to file, and I'm going to name it NDBI 2025 Nairobi. Then save, click on save, then you're going to click on run. So our clipped area of interest is already generated. Toggle off the NDBI layer for 2025, and now we have this. And you're going to do the same for NDVI layer for 2020 and NDVI layer of 2025. Now we have our NDBI and NDVI images. And for NDVI, standard values always ranges between -1 to +1, where for NDVI values less than 0 always represents no vegetation, and for values greater than 0.2 always represent vegetation. For NDBI, values less than 0.0 represent non-build-up areas, and values greater than 0.2 represent build-up areas. So if you look at this image with this type of color scheme, you cannot identify most of the features in the image. So what we're going to do next is class, and I'm going to right-click on our layer, then choose property. Render type, we're going to select on single band pseudo color. For interpolation, I'm going to use discrete. And for our color ramp, I'm going to scroll to all color ramp and choose on red to green color ramp, and make sure it's inverted color ramp for the NDBI image. And for mode, I'm going to use equal interval. So I want to use 4 classes. I'm going to remove this class with the orange color by clicking on it, then clicking on this minus sign. So I have 4 classes for my classification. Then I'm going to click on apply. So this is our NDBI image. Let's do the same for an NDVI layer for 2025. Make toggle on, right click, then properties. On the symbology pane and under render type, I'm going to select on pseudo color. Interpolation, I'm going to use discrete. Our color ramp, we're going to use red to green. For mode, I'm going to use equal interval. I want to have 4 classes for my classification. Do away with the orange class. Then I'm clicking on remove selected rows. After that, I'm going to apply, then OK. So this is our NDVI image after classification. Let's do classification for the others. Our next step is extracting build-up areas. We're going to click on raster. Then we're going to click on raster calculator. We are going to input our formula for extracting build-up areas. Let's click on bracket. Then I'm going to select on NDBI for the year 2020. Click on greater than. Value, we're going to input 0. Then close it and use the operator and. Let's input the bracket first. NDVI for the year 2020 is less than 0.2. Close the bracket. Let's save the layer as urban 2020. Then click on OK. And now we have our layer for urban 2020. The output shows values ranging 1 and 0, and for 1 it's for urban areas covered with urban, and for 0 areas covered with non-urban areas. So this is called a mask, and this converts our continuous index images into a simple urban or non-urban classification. By combining NDVI and NDBI, we reduce spectral confusion and improve classification accuracy for urban expansion mapping. Now you're going to do the same for the year 2025. Next step is detecting urban change. We're going to subtract urban layers. So let's click on raster, then raster calculator to input the formula for subtracting urban layers. Let's input our bracket. Then we're going to subtract the urban 2025. You subtract urban 2020. Urban 2025 subtract urban 2020. Then we're going to save it as urban change. Then click on OK. So we have our urban change layer calculated. Let's interpret the results. So for values, +1 represent new urban areas, and values representing 0 means there's no change, and values representing -1 means lost urban area. So I'm going to do some post classification for this layer to make it a little bit visible. So I click on the layer, then property, and under the symbology pane and render type, I'm going to use palette unique values, and then click on classify. So I have 3 classes, but we're going to use red to represent 1, and gray to represent 0, and blue to represent -1, whereby red represents growth, and blue represents loss, and gray represents stability in growth. Let's change 1 to red. Right click, then change color. I'm going to use the red color, then OK. Then for 0 we're going to use gray color. Okay, and for -1 we're going to use the blue color. We're going to use blue. Okay, then click on apply. The reason why we did our post classification is for better visualization, and I styled urban pixels in red and made non-urban areas transparent to clearly highlight expansion patterns. So let's change the transparency of the gray region to 30%. Right click, then opacity. I'm going to change it to 30%. We're going to do classification for our urban layers for 2025 and for urban year 2020. So let's toggle this off. Urban areas are represented by 1, and non-urban areas are represented by 0 value. And let's do a post classification for that. Right click on the layer, then properties, under symbology pane. I'm going to use palette stroke unique values, then click on classify, and now we have 2 classes for our classification. I'm going to make 1 to be red and 0 to be gray. Right click, change color. Let's click on gray. Okay, then click on apply, then okay. I'm going to change the transparency for the gray color to be 30% by right clicking on that color, then opacity, then we reduce it to 30%. So this is our image for urban 2025. Yeah. Now let's calculate urban expansion area. So we're going to convert the raster to vector, and I'm going to click on raster, then click on conversion, then click on polygonize raster to vector. And I'm going to save our output as urban change shapefile. Let's click on this drop down to save our file. Urban. Then click on run. And now we have our raster converted to vector. To calculate the area, I'm going to right click on our urban change file layer, then click on open attribute. On the attribute table, I'm going to click on open field calculator. Our output field name, I'm going to type area in hectares, and I'm going to input my expression to calculate the area. So let's search on area, and I'm going to double click on area and divide the area by 10,000. Then click on apply. So the area field is added, and these are our areas in hectares. Now let's filter out the new urban areas. We're going to click on select expression. Under field and values, I'm going to click on dn equal, and value we're going to input 1. Then click on select features and then close it. Now I've changed our urban vector isolated field to no field. So what you're going to do next is to see the static attribute table of the selected features. So I'm going to click on processing. Then under processing, you click on toolbox, and processing toolbox pops. You're going to scroll to where vector analysis is and click on the drop down. Under the drop down, I'm going to select statistics by category, and the input layer is urban change vector, and the field statistics are going to use area in hectares, and make sure selected features button is on. And now let's save our file. To save the file and name it new urban growth statistics. Then save it. Before we click on run, make sure you select area in hectares field. Okay. After that, you're going to click on run. And now we have our statistic for our new urban change growth areas. And now if you right click on the new urban statistic and click on open attribute table, you have a table with the minimum and maximum values for areas in vectors, the sum, the mean, and the median, and so many others. Now we have our new urban growth statistics. So let's click on the tool for statistical summary to view urban growth. So the total urban expansion between the year 2020 and the year 2025 is 5,378 hectares, indicating a significant spatial growth. The summary for statistical values of the mean, the median, and standard deviation. Today, we've successfully performed urban change detection using NDVI and NDBI in QGIS for the year 2020 and the year 2025, and generated our urban expansion map. In the next video, I'll show you how to design a professional print layout and present the final analysis properly. So make sure you subscribe, like this video, and turn on notifications so you don't miss the final output. See you in the next lesson.